Hello everyone, welcome to one more of my videos, and today I'm going to demonstrate a payroll management system code in C++, and this application is PayApp. So I'll run the code, let you see what it does. So for the video, if you do like the video, give it a like. If you're not sure, choose to like. So this is the interface. Options, I will start first with the first option, which is close application. So yes, it's closed. Rerun. So far there's no files, so let's create. Go into department, other department. All right, so it's asking for the department code, so unique identifier, department name, probably IT. Well, the rate, I can say 70 per hour, overtime rate 105. That should be right. Okay, successful added. As you can see, this is the file now. The information is there. Let's add the next one. Okay, successful added. So let's quit. Alright, could I, well, let's view. So these are the records that are presently existing. So let's come out for now. Employees. So you can view sorted or single employee record. So far there aren't any record as yet, so the file is not opening. So let's add an employee. Alright, so the employee will need ID, the person, employee name, alright, so has to be to a department, and the position developer. Okay, that's correct. Hours work, probably for the week 50 hours. Alright, let's see. Number 4. So before it was throwing an error because there wasn't any file to read from. So now you can see the employee is there. Alright, let's add the next employee. Manager, hours work. Okay, so successfully added. Let's, so okay, employee. Okay, the ID. So the employee information is here, and it create a payroll text file. Should let us see what the structure is for that information. Alright, let's come out. Alright, so let's check employee payroll now, monthly payroll. So let's view number 3. So there isn't any record currently. So let's process the payroll. Alright, so it has been processed for 2 employees, Pam and John. Alright, so I can actually view a single payroll if I need to, and I will use the employee ID. So 201. Yes, I'm able to see John record. So let's come out of this. Alright, so view all records. So, and it sorted, records are sorted by these criteria. So ID, last name, department code, position. So let's check department code. Okay, so it's sorted by department code and it's ascending order. So you have Pam, you have John. So let's check by last name. So as you can see, ascending order by last name, and position. Let's see position. Okay, so based on position, developer, manager. So before I continue, I will give you a rundown of the code and its structure. So let's see software solution now. That is the name. So this is the information. So the scenario for this, or should I say the analysis, business analysis, is that smart solutions now require a new system to replace its outdated payroll application. So the manager of the department has requested that the payroll system be replaced given their expansion, and they are no longer able to facilitate the old payroll based on the system. So for this, the manager has requested that it should have CRUD, which is create, read, update and delete. So let's go back to this. Alright. Alright, so for the department, for instance, look, you will have add, which is create, update, view and delete. Alright, so this is also a criteria pertaining to payment, that regular hours are paid at regularly rate for 40 hours, and beyond that is overtime at time and a half. And this is the structure of the files. As you can see, for the department, you will need to have the department code, the department name, the hourly rate, overtime rate. And for the employees, you will need, for an employee, you will need ID, the first name, last name, and the department code and their position. And for the payroll file now, you combine this information, and with the exception of gross pay. So user requirement is that for whoever using the system, such as admin and HR, they are able to add, view, and you can view all, or you can view by the specific code, and you update and delete, and then the data will be saved, so for future use. So that's the reason for persistence. And then for the employee management is similar, with the exception, or should I say additionally, with the criteria to search based on the sorted order. So the ID, name, and additional information. And for the payroll, it's similar. You have this CRUD same way, and then the calculations for the regular pay, overtime pay, and then the employee gross pay. And the functionality as expressed before, the data has to be saved for future use. And then this is the structure of the class. There are the classes. So you have the department, and these are the attributes, and then you have the different methods. Similar for employee, then you have the emp list, which keep the nodes or store nodes for the date, the employee data, and similar payroll and payroll node and the list. So this is a relationship of the different classes, and give a short overview. So the department and employee have a one-to-many relationship. So basically is that you can have one department having multiple employees. So for IT, you can have multiple IT related employees. So that is a one-to-many relationship. And then you have employee having one-to-many payroll. So one employee can have many payroll historically. So the first month they will have one, and continuously after the first month they will have many more. And then you have the relationship between the emp list and the employee. So really is that the list is keeping or storing employees. And then similar for the pay list, you have payroll storage, and this is an aggregate relationship. And then you have the emp node and the payroll node, which have a composite relationship. So if you can understand how a list works, you'll have to have node added to it and link until from the head go down. So that's really it. And as for the class, these the description, short description of the class. So for the department, you have encapsulation. Well, each of them have encapsulation, which is much secure for data storage. So what encapsulation does is ensure that only what needed to be exposed or accessed is accessed. So I'll go back to the code to further see the functionality. So alright, I was in department, so let's get out of this. Employee. So whenever check the delete as yet, but I will do a view first. So I'm gonna view employee. So look for this employee, which this ID is so Pamela. So Pamela is there. So I'm gonna go back after exit, and then I will delete. And it's give a prompt. Do I want to delete? Are you sure you want to delete? Yes, that's the reason why. Oh well, check no first. Okay, so I said no. Let's check. So I said no. Pamela is still employed too. Well, it's still an employee. So let's delete now. Okay, yes, I am sure. Okay, let's look. View. So it's only one employee currently since Pamela records has been deleted. A record. Okay. So these things are interrelated. So let's check the payroll. Alright, so I'm gonna view all the payroll. Okay, so I see. Since that is there, I'll just reprocess, ensure the system is updated. yes, so this is it. So only one record has payroll information, which is John. So let's view all. Okay, yes, so it's only John. Alright, so for payroll, you're able to process the payroll, you're able to view, and you're able to delete. Why didn't I really add update? It's much better to update information from the department or from the employee section, because you don't want to have information misaligned. Like for a payroll, you're going to edit a person name or something like that, or you're going to edit the department rate. So it's best to edit these information directly from each area or section. So let's go back more. I'm going to add another department. Alright, let's add a department. Department. So research and development. Alright, this is big business, so probably $100 hourly rate, 150 overtime, successfully added. Minus 1. Alright, 4. Let's view. It's there. So since research and development is big business, for instance, probably the employees are doing much more, so they need to be paid more. So I'll do an update for this. Number 2. Alright, update. Alright, so R&D, what about the name? Hourly rate, probably 200. Costly. Overtime rate 300. Okay, updated successfully. Let's view. Alright, so let's go to employees. Oh, that wasn't correct. Add employee. So 301. Billion. Okay, so department position. What was that? Okay, so okay, data analyst, so hours work, so probably 30 hours. Alright, let's find out. Payroll for this person. So view payroll. So there's only one person so far. Reason being, the payroll hasn't been processed as yet. Alright, so let's process. So yes, has been processed. Okay, let's view. Right, by department code 3. Okay, yes. Alright, analyst. Okay. Alright, so let's go into the structure of the code I started from department. So the department header file, as you can see right here, so the attributes, and then you have the destructor right here, the default constructor, alright, and then primary constructor, prioritize constructor, whichever name is okay, and then the copy constructor. So for the copy constructor, as you can see, it take a reference of the department and it say it's constant, so it promise not to change this information. So what the copy constructor does is allow one object of the department to copy to another. So without this, it's that copy of values or reference is not possible. And then we have the mutators, which really set the values, or setters also, and the accessors, which really get the value. So this is able to get the value and return it. Alright, so let's go into implementation. Alright, so for the files, they are set as constant here. Why? It's much more flexible in the sense that you don't have to rewrite the file every minute, or the file name, which create a greater degree for error. And the destructor right here, constructor, default constructor. So if you create a constructor and there's no information added, this will be the output, default information, and then the parameterize or the primary constructor information right here. So these information are entered into the constructor, and the copy constructor, which pass in a reference to copy one object to another, and how they explain the mutators and the accessors. And this is just the header for displaying information, and then this display the information. So you will get the code, get the name for the department, the hourly rate and overtime rate. This is just the value, the information inputted, so you're able to validate the rate and then use this function to create a department. So pass in the code and then enter the other informations. So the file access, the input stream to read to create a file, output free to write the file. So why you have an overload situation is because you're gonna accommodate output stream, file output stream, and file input stream. So overload the function so it can take in different arguments, and this return a bool to say, hey, the file is open successfully. So when it says check, so not successfully, so if not successfully, if file not successful, then return, otherwise go forward with this information. So check, if it's not created, throw an error. And then this allow you to create the file information and the overall function to create the file. So right here, ensure that all information that are entered not empty. Go forward, check the file, ensure it's open. Go forward, this to check if the file already exists. So file in the record already exists. So first, before you go forward, check for the duplicate code. If you find the code already exists, it's not, check for the name. If the name exists already, give this information it exists. Otherwise, if it exists, come out, return. Otherwise, proceed, accept the department file, the rate file, and a department object, and store it. Move on to update. The similar function to up top as in add is similar, except you'll need both input and output file stream, one for read and one for writing. So you read right here to check if the record is found, and then if it found, you use this to write. So for this purpose, you will need a temporary file to store the information temporarily. Get rid of the original file and then rewrite the name of the original file to the temporary file with the updated information. So as usual, I use a bold to see if the file was found, and then the vector right here allow to store the ID and the department name to check if they exist. So while true is really infinite loop, and while infinite loop, you will stream this information if it exists. So the department file, you'll stream the code and the name. So why use get line is that I want to get the complete information. So usually if you do not do this, you may have, for instance, research and development in full details. It may just return just the research section and not the development, because it's a full line. So where the white space come in, it's more likely will skip that section. So read from the rate file. So continue. So if not, these information not in the file, end of file, if the file is empty, it will break. Otherwise, continue and then store the department code and name to check. So if the code is found, so you check both the rate file. So for a department, it has to have a rate. So you need both file, the department file with the name and the code, and then the rate file, which is the code, and it will have the hourly rate and the overtime rate. So once information is found, then create an object for the department to update. So we'll check, ensure the object is showing the information, and then create updates. So this allow information to be entered, so you can use by the same create function. So duplicate, use this to confirm the duplicate, check to it. So if it is found, return true and say duplicate name already exists. And if duplicate, keep back the original file. If not, you create the temp data, temp file, and use the update. Hold on, the update information. Alright, so you will have this if right here. So if not found, else you use but the original information if it was not initially found. So going forward now, you close the file since they are out of scope, no longer needed to be used, and remove the original files, which would have just have the original information, and keep the updated files and rename them the original name. So that complete the update section. So the view record now similar, you just only need the input stream to read. So check. So while you have information for department file, you check the code, department name, read those, move on. So if the rate file not empty, you get the department code, hourly rate, overtime rate, and then you confirm. If it's true, you display the information. So if it's not found, you give this information it does not exist. The file out of scope. The files are out of scope, so you close at this point. Well, for the view all records, similar to the single record, the only thing is that you just continue until you reach end of file. So that's what this is really saying. Just continue until you reach end of file, and you continue to display the files. And this is checking if there are record there. So if the counter checking and there's only 0, meaning no file, it returns that there is no file existing. So the department now, so if I want to delete a record, it's a little bit similar to the update. So you need the input stream for reading, output stream for write, and the temporary files to store the information. So as you can see now, similar as you read before, don't want to go through this. Check if the department code for delete is both in the department file and the rate file, and if it is found, display the creator object with the information and display it. So this now you use to confirm if you want to update or not, or well, let's delete my error there and move forward. And similar before, as I was saying, if delete yes, then delete is true, and you move on to the information. So as I was saying right here now, if it wasn't found, then you will write back the original information. Let's see. Alright, so if found true, you go ahead and check. If it's not, you write back the original information to the file. So you put in the temporary file, temporary rate file, and the department object. Set out of scope now, so you need to close back the files right here and move along. So if not found, keep back the original code. Found and delete, that means you found, it was found, and you also choose less, yes. You'll remove and rewrite the original file name. Otherwise, you would not need to use the temporary file if it was not deleted. So you just remove them. So that concludes the structure for the department. And for the employee, it's, where is it? The employee, okay, yeah. The structure is similar. As you can see, the decoration of the files as constant, and the constructors. So you have the destructors, the default constructor, the primary constructor with accept parameters, and the copy constructors, which you're able to copy one object to the others, the mutators to set in values, the accessors to get in the values, and then this just used here to help structure the display header. Alright, and then you're able to show the information, the ID, first name, last name, department code, the position, and the get hours, the hours worked. And similar, you have the function to validate string input, to validate int input, and to validate float input. So more likely for the hours work, use it to validate, and then create an employee function, file access for input stream, output stream, and return a bool and allow override. So similar, have a function to write to the record. So moving forward now, with the ensure to check into the file, check for the person name, first name, last name. If that first name, last name exists, then say yes, already exists. Duplicate information being entered, first by the ID and then the name. Check the first name and last name and then write to the file. Alright, and this information here just to say yes, it was successfully added. I don't want to get into this too much, but it's similar structure to the department update. We'll check to ensure that the ID was found before moving ahead and updating it. Similar for view all record, check to the record. Well, this is for a single record. Check to the record once the ID is identified, display the employee information here. So you have the header and then the display function. If not found, you will say yes, it's not found. Similar for the view, you check all the information and then display. If there is zero record, then nothing exists. There's no file. There's no record. So for the deletes, similar, you check to the file, ensure the employee ID is found, confirm if you want to delete, and then yes, move ahead, delete found, delete true I should say, and move forward. So close the file, then here. So if yes, continue. If not, cancel. Keep but the original information just as this. So this is similar to this. You keep at the original information. So if I say no, keep at the original information. If not found, you keep at the original information. And then, well, similar right here. And then if it is found and delete confirm, then you need the temporary files and remove the original file and then replace. So let's go into the pay list right here. The pay list. Alright, so the pay list allow nodes to be added. So let's check the peer node. So get back the original information and then there's a delete display function right here, and then the nodes, you have the destructor, constructor, and the setters and the getters. So let's move back into the list. Pay list. Okay, yeah. So for the pay list now, as you can see, taking a payroll here, and it also taking a payroll node, and then the header function for the pay list. So you have this pointing to head, the constructor, and then the destructor. So this release back whatever memory that was allocated dynamically, and this function check if it is empty. So checking the head, nothing is there, that means it's empty. So you move on, dynamically allocate memory to temp. So you want to return true if it is full. So you say if fails, the list is considered full. So if it's not empty, it is considered full. Delete return false. Alright, otherwise it's true. So to insert at the front, ensure that the list is not full before allocating memory to a new node. So what this is doing now, if the new node is not null, move on, set it to the next, which is head, set next to head. So it's storing information and moving forward, and it is payroll information or payroll data. Right here you're able to count the amount of nodes or object in the list, and this, once it's not empty, you're able to display. So once the current node not empty, display and continue. So what the get next is to move on to the next node. That's what the get next does. So the merge sort now, so that was used to sort the different criteria, which was the ID, the last name, the department code, the position. So for the merge function right here, the ID, each of them are similar, so you can see is to set head to the merge, and what the merge sort does is take in a head, additionally two reference to A and B, well, two different node reference, two different reference to the payroll object. Yes, that's what it does, and it does it for each of the sort one. So let's look at this now. They said split and get the middle. So this get the middle of the list. So let's get the middle of the pay list. So firstly, getting the middle, it's saying that if not node, that means that nothing is empty. So there's no middle there, return. Otherwise, you have the first and the second. So the first is the starting point, the second is after the starting. So getting the middle here, it is saying that this second and second get next. So how this get the middle is that one is moving one step and the other is moving two steps. So if you have 5 and 2 times 5 will be at the end, that is 10. So basically 5 will be the middle. So that's what it's saying, one move singularly and the other move twice. So this will be at the middle and this will be at the end. So return first, which is the middle. So as I was saying, first will be the 5 and the second would be the 10, because this is going twice amount of this. So in simple term, that's what it really means. Alright, so the main merge part here. So now to start, and the information, or should I say the arguments, a reference node, a function that compare two reference to payroll. So right here now, if If not node, there's nothing, it's already sorted. Otherwise, check get next. So if it's get next, there's only one node, return, one node is sorted. Otherwise, you get the middle, so you split it, get the middle, and then you check the other section, which is the next after middle, which is the other part. So you split it in the middle and then store it in the middle, and then the other section after the middle, you store it in the next after middle, and then move on and compare. So to compare, take in the node and compare. So compare. So the concept of this sort function is really what it does is that split the overall list down into smaller sublists, and once there's only one singular object in the, or should I say item in each sublist, it go ahead and remerge back the list into a sorted list. So right here now it's going to remerge, so it's saying that if not left, it's only one right, so that is already sorted, so return right. Similar, if not right, return left, because there's only left there, so it's already sorted. Otherwise, go forward and compare the left data with the right, and then move on to the next object or the next data and store it. Set it the left set next to the merge data compared to the right. So what it does is really comparing the right and the left and setting the data to move on to the next sublist, and a similar thing is done right here. Alright, so let's go back to the code. I will leave some more comments so it can be clear enough. Oh wow, this thing take kind of a while. That's how long I'm in. So I'm going to try to close up this tutorial now, because it has been a while. I didn't realize. So where was I? Okay, payroll. Hold on. Okay, so number 2. No ID there. Alright, so I want to say thanks for watching. It has been like a while. I don't want to go any further with this tutorial, but depends on my feeling. I may go forward and add another section to this. Why I like C++, when I was doing my studies, I started out with C, and then when I was doing certain projects, I was given the option of using C++ or using Java. But I heard that C++ was a little bit challenging given the expectation of pointers and so on. So I said, okay, let's see what it is, and I chose it. I liked it. And the main thing about using C, if you're able to use C, you're able to also, well, C++, you're also able to use Java, because Java, well, C++ syntax is similar to Java. So it's, once you learn C, it's much more easier to learn Java than learning Java first. So I want to say thanks for watching, and see you again with the next video.